Hi guys, Mr. Thiera here again. Um, Before we start, just want to say hope everyone is doing well. Hope everyone's staying safe. And please continue to try your best with this online learning. I know it's not really ideal for anybody and it is difficult, but I know you guys are trying, and all I ask is that you keep trying your best and ask any questions whenever they do arise, and I will do my best to help you. Okay, so let's move on to today's lesson. So it's going to be on exponent rules. So this is the first lesson of Unit 4. Before we get into the actual rules, just a bit of terminology here at the top. Here we can see what each part of the power is called. So this entire b cubed here is called the power. So the power is the base with the exponent. The base would be the b in this case, and then the exponent is obviously the 3. Okay, so that's just a little bit of terminology for you. And then what does b cubed mean? I think we probably all know, or hopefully know, that b cubed would mean b times b times b. Okay, so moving on to number 1, it asks us to simplify the following. So 2 cubed is just 2 times 2 times 2, which gives us 8. Okay. 2 to the power of 4 is just 2 times 2 times 2 times 2, so 4 times altogether, which gives us 16. And same thing here. Same idea here, but the difference is our base is negative, so negative 2 to the power of 3, or negative 2 cubed, is negative 2 times negative 2, which is positive 4. And then multiply that by negative 2 gives us negative 8. And then negative 2 to the power of 4 is negative 2 times negative 2 times negative 2 times negative 2. If you go ahead and do that, so we can do negative 2 times negative 2 gives us 4. And then this negative 2 times this negative 2 gives us 4. And notice how these are both positive. So 4 times 4 gives us positive 16. Okay, so what are we trying to show you here is what is summarized here in this box down here. What can we say about negative number bases raised to even exponents? So if you have a negative base, like we do here in C and D, and the exponent is even, okay, so like we do here, your final answer or your result will be positive. Okay. Second part here, if you have a negative base and it's raised to an odd exponent, like we do here, like to the power of 3, you'll get a negative result, like we did here, negative 8. Okay, so just keep that in mind. With negative bases, if it's an even exponent, you get a positive result. If it's a negative exponent, you get a negative result. Okay, moving on to number 2. If possible, express each as a single base with a single exponent by expanding first. Okay, so first we need to expand and then simplify. So if we have 2 cubed, we know 2 cubed is 2 times 2 times 2. And then multiply that by 2 squared, and we know 2 squared is 2 times 2. So to express this as a single base, what do we have here? We basically have 1, 2, 3, 4, 5 2's. So to express that as a single base, it's 2 to the power of 5. Okay. For b, we have negative 4 squared and negative 4 to the power of 1. So if we expand negative 4 squared, it gives us negative 4 times negative 4. Negative 4 to the power of 1 is just negative 4. So now we have 3 negative 4's multiplied by one another. So to simplify that, it's simply negative 4 cubed. Okay. Before I move on to C, so just the shortcut, or the quick way of doing this, instead of expanding like we did here and here, if you've noticed, really what the final answer is, when we're multiplying with the same base, we add the exponent. So here we have the same base, base of 2, and we're multiplying, so we just add the exponents together. So that 3 plus that 2 gives us 2 to the power of 5. Here our base was negative 4, and we had negative 4 squared and negative 4 to the power of 1. So we do 2 plus 1, which you can see there, gives us negative 4 to the power of 3. Okay. The one thing to keep in mind is we could only add the exponents like we did in A and B when the bases are the same. Here in part C, the base is 3 for the first power and the base is 5 for the second power. So as soon as you see different bases, we cannot add the exponents. We can only add the exponents if we have the same base. So that is our first rule here summarized. Same base rule if you're multiplying the exponents. So when you're multiplying two powers with the same base, you keep the base and add the exponents. Okay, so the base stays the same, you just add the exponents. So there's your multiplication rule. Moving on to the, sorry, I think I missed one. There we go. The next part here, express each as a single base with a single exponent by expanding and canceling. So same question, but instead of multiplying, we are now dividing. So if you look at basically any of these questions, A, B, C, or D, they're done in the same way. So let's look at the first one here. 9 to the power of 5 means 9 times 9 times 9 times 9 times 9 over 9 squared. So 9 squared means 9 times 9. Once we have that written out, we can see 5 9s on the top and 2 in the denominator. So we can basically cancel out 2 of the 9s. So we cancel out 1, 2 with 1 and 2 down here. So what does that leave us with? 9 times 9 times 9, which is 9 cubed. Okay. So the rest of these questions are all done the same way. 7 to the 4, you have 4 7s in the numerator. 7 squared, you have 2 7s in the denominator. So we can cancel out 2 of the 7s in the numerator with these 2 7s in the denominator, leaving us with 2 7s, or in other words, 7 squared. Okay. So what are we doing? And you can see here off to the sides, when we are dividing exponents with the same base, we basically subtract. So we have 5 in the numerator, power of 5, and power of 2 in the denominator. So 5 minus 2 gives us the 3. So the base stays the same, and the exponents we subtract. 7 to the 4 over 7 to the 2 is the same thing as 7 to the power of 4 minus 2, which gives us the 2 there. Okay, so you can see the same thing in part C and the same thing in part D. So we don't always want to expand. So imagine expanding 56 to the power of 100. You don't want to write 56 times 56 times 56 100 times, and then 56 to the 99. Write 56 times 56 in the denominator 99 times. So we can just simply do 100 minus 99. Which gives us 56 to the power of 1, which is the same thing as 56. Okay, so summarizing that rule, when we are dividing two powers with the same base, we keep the base and subtract the exponents. Okay, moving on to the next part, express each as a single base with a single exponent by expanding first. Okay, so to expand something like part A, we have 9 squared in the bracket, and it's 9 squared. All of that is cubed. So basically what we're saying is 9 squared cubed is equal to 9 squared times 9 squared times 9 squared. And now we know from our multiplication rule that when you are multiplying exponents with the same base, like we are doing here, right? The base is 9, the base is 9, the base is 9. We add the exponents. So 2 plus 2 plus 2 gives us 9 to the 6. Okay. Same thing here, 5 cubed to the power of 4 means 5 cubed times 5 cubed times 5 cubed times 5 cubed. So same base, and we're multiplying. So what's happening here? 3 plus 3 plus 3 plus 3, which you see there. So 3 plus 3 plus 3 plus 3 is also the same thing as 4 times 3. Okay. And the exact same thing is happening here. 2 to the power of 20 cubed is 2 to the power of 20 times 2 to the power of 20 times 2 to the power of 20. Again, we are now in this line here multiplying with the same base. So you do 20 plus 20 plus 20, add the exponents, which is what we have written here. That 20 plus 20 plus 20 is equivalent to 3 20s, right? We have 1, 2, 3 20s we're adding. 3 times 20 is what's written here, which gives us a final answer of 2 to the 60. So what is this showing us is basically in a long way, by expanding all of these here above, it's telling us what we do when we have a power to a power. So what are we doing when we have a power to a power? If we have 9 squared to the power of 3, we multiply the powers together. So we do 2 times 3 gives us 9 to the 6. What do we do when we have 5 cubed to the power of 4? We multiply the powers together. 3 times 4 gives us 5 to the 12. Same thing here. We have power to a power. So 2 to the 20 to the power of 3. We do 20 times 3, which gives us 2 to the power of 60. Okay, so summarizing our next rule, if we have a power to a power, we multiply the exponents together. Okay, so just like we did in A, B, and C above. Okay, so multiplication rule, add the exponents together when you have the same base, division rule, subtract the exponents when you have the same base, and power to a power, multiply the exponents together. Okay. Moving along to our last one here. Simplify the following by expanding first and making use of the exponent rules. Okay, so when you have an exponent like you do here, the 2 outside of a bracket, that 2 needs to apply to each term inside the bracket. So what I mean by that is that this 2 here has to apply to the coefficient 2 and also to the variable a. So if we expand this, basically it becomes 2 squared times a squared. And to simplify that, 2 squared is 4, and then a squared just remains a squared. Okay. The other way you could have expanded this is 2a squared means 2a times 2a. Then we multiply the coefficients, 2 times 2, which gives me this 4 down here, and then a times a gives me a squared. Okay. So the same thing applies when we have a fraction. Okay, so the power of 2 is outside the bracket, so that 2 now needs to apply separately to each coefficient and each variable in the bracket. So this power of 2 has to apply to the 4 separately, then has to apply to the x separately, then has to apply to the 3 separately, like you see over here. Once you do that, you can simplify the 4 squared, which gives us 16, and the 3 squared, which gives us 9. Okay. Again, the other way to do this would be to say 4x over 3 squared is just 4x over 3 times 4x over 3, and then expand that way. The issue with doing it in this way is if you have large exponents, so if it was 4x over 3 to the power of 9, let's say, you don't want to sit here and write 4x over 3 times 4x over 3 9 times. So you want to familiarize yourself with this up here and this rule, which tells us that you need to apply the exponent outside of the bracket to each coefficient or constant in the bracket and each variable in the bracket. Okay, so summarizing our power of a product rule, when you raise a product or a quotient, okay, so what we mean by that is a product like 2 times a in the bracket, or a quotient, which just means a fraction basically that you're dividing, 4x over 3. Anytime you have either of those to an exponent, you apply the exponent to each number or variable individually. Okay, so just like we did up here, we applied the squared to the 2 and to the a. We applied this squared to the 4, to the x, and to the 3. Okay. Once you apply the exponent to each variable and each number, then simplify where possible. Okay, so there are all of our exponent rules, and you can see them summarized here. So just to summarize once again, if you have the same base and you are multiplying like we are here, you add the exponents. If you have the same base and you are dividing, you subtract the exponents. If you have a power to a power like you do here, you multiply the exponent. So in this case, it's x times y, which gives us b to the power of x times y. And the last one we just discussed, if you have a product in the bracket raised to an exponent, make sure you apply that exponent to each number and each variable inside the bracket. So you can see here the x is applied to the a and to the b. And then the same thing if you have a fraction or a quotient, basically meaning you're dividing. So same rule, apply that exponent to each number and each variable inside the exponent. So you can see here inside the bracket, So you can see here the x was applied to the a and the x was applied to the denominator, which is the b there. Okay, so I'm pretty sure most of you guys have seen some or all of these rules before. If you haven't or if you don't remember, no worries. That's why we went over them today. So please familiarize yourselves with these rules. You're going to be using them. And as always, if you have any questions whatsoever, please feel free to email. Let me know, and again, I will do my best to help you in any which way I can. Okay, so there's lesson 1 of Unit 4, and take care, guys, and good luck with the studying.